Hello, this video is about quiz 6. I still caught a cold, so please pardon my voice. I'll try my best, and I'm having a candy in my mouth, so please understand that. So let's go. By the way, this chapter is about normal distribution, and this chapter is pretty algebraic part. So I recommend you to open Excel by you so that we can calculate normal distribution probabilities directly from Excel. Okay. So first question. Suppose that X is the daily highest temperature measured at Albany International Airport in Celsius. We transform X into a new random variable Y, which is the temperature in Fahrenheit. The conversion formula is linear. So X follows a normal distribution with mean 55 and a variance 120. What is the distribution of Y? So just warm up, simple question. The key here is, this is a very important theorem. A linear transformation of a normal random variable is also normally distributed. So that is an important property of a normal distribution. And then we know that X is normal, so Y is a linear transformation, so Y is normal. And then what remains is we just need to know the mean and the variance of Y, right? So because normal distribution is parameterized only by two numbers, mean and variance, so it remains to find the mean and the variance. And we know how to do that for a linear transformation. Mean just follows the same linear transformation form, and variance is multiplied by square of the multiplicative constant, right? So I would write it this way. You can plug in the numbers 55 here, 120 here, then you will get the new mean and the variance. Then they are the parameters for the new random variable. Pretty straightforward. Next question. Suppose that a random variable X follows a normal distribution with mean 10 and variance 16. Let Z be a random variable following the standard normal distribution. You are interested in the probability that X is greater than 12. After standardization, what probability it will become? So it asks you to do the standardization. That's it. Pretty straightforward. We know X is normal distribution with mean 10 and variance 16. But for standardization, you need standard deviation instead of variance. So I would write it this way. Instead of 16, I will write 4 squared. Okay? And then just follow the standardization step. We want to know, we are interested in probability greater than 12. And you are going to transform, like standardize X by subtracting mean and dividing by the standard deviation. So I do that in the same way on the right hand side, on the other term. So I'll just calculate that. 2 divided by 4, so it's 0.5. So this is a probability in terms of standard normal distribution. So you can calculate that. You can choose the correct option from the options. Next question. Suppose that you are in charge of the catering for a company meeting. The expected number of people for the meeting is 96 with a standard deviation of 8. If you order 100 sandwiches, what is the probability of having more people than sandwiches? So you have to feed in a meeting all the people attending the meeting, and then you are not exactly certain about the number of people attending the meeting, but it is I didn't say, I should have said it is normal distribution. I'm sorry, I missed that, but we are doing normal distribution chapter, so it should be obvious. So we define x as the number of guests. It is random, and we assume that its mean is 96 and the standard deviation is 8. So we can write it this way. And we are interested in calculating probability x is greater than 100. So this is the case when you are in trouble. You ordered 100 sandwiches, but there are more than 100 people, so you are not doing your job well. Anyhow, so to do this, we are going to follow 3 steps. First, you are going to standardize the probability, transform x into z by taking this form, right? And you are going to transform the other side in the same way, right? Mu is 96, so subtract 96, and sigma is 8, so divide by 8, and you can calculate this number, which is 0.5. And then step 2, this probability is about standard normal distribution, but this is not a cumulative probability. What we need is cumulative probability that of this form. So probability greater than 0.5 is not available on Excel, but what you can obtain is probability smaller than 0.5. So you have to take 1 minus that cumulative probability. And then in the third step, use Excel, right? You may remember the formula we need is NORM, normal distribution dot standard dot dist, norm dot s dot dist, and we are interested in the 0.5, the value 0.5, and we are taking cumulative probability. So enter this, you get this number, right? 0.96146, 69146, right? So this number is for this cumulative probability. So you have to subtract that from 1. So also do that on Excel. Then the answer is 0.30854. So more than 30%, there will be more guests than the sandwiches. So you have to order more. Okay. Next question. The lifetime of traditional light bulbs measured in hours is known to be normally distributed with mu 100, sigma 20. What is the probability that a randomly selected traditional light bulb will have a lifetime of 85 hours or longer? You can ignore that. Same question. We know, like we define a random variable x as the lifetime of a light bulb, and we know its mean and standard deviation is 120. We are calculating probability greater than 85. Identical structure to the previous question. You are going to standardize. Probability greater than 85 becomes z greater than 85 standardized. 85 is standardized to become minus 0.75. So they are equivalent probabilities. And again, this is not a cumulative probability. So you have to turn this inequality to the opposite side, right? To the opposite direction, right? So we are calculating probability z smaller than minus 0.75 and take 1 minus that. That is our desired probability. And then go back to Excel and calculate that probability. Norm.s.dist. Now the value we are interested in is minus 0.75 and true. You get 0.22663. That is the cumulative probability we need. But what we need in the end is 1 minus that. That is 0.77337. So nearly 77% of light bulbs last longer than 85 hours. Okay. Next question. It is known that the amounts of money spent on clothing in a year by college students follow a normal distribution with a mean of 325 and a standard deviation of $50. What is the probability that a randomly chosen student will spend between $300 and $400 on clothing in a year? Another similar structure question. X is the spending on clothing by a college student in a year, and then we know its normal distribution. So then we are going to standard when we would like to calculate this probability between 300 and 400, right? This probability will be standardized by subtracting 325, the mean, and dividing by the standard deviation 50, right? So remember, there are three terms, two inequalities and three terms. To keep those inequalities unchanged, you need to standardize all three terms, right? So x becomes z, and 300 is standardized to become minus 0.5. So subtract mean and divide by standard deviation. And 400 becomes 1.5. So, so you expressed the probability using a normal distribution, standard normal distribution, right? And second step, we have to transform this probability to cumulative probabilities. So we don't have the value on Excel like this. So we are going to, like, probability on interval with two endpoints can be written as difference of two cumulative probabilities. The probability smaller than the larger number minus probability smaller than the smaller number, right? Here I included there is no equality here, but I included equality here because technically cumulative probability is defined in this way, but it doesn't matter to include 1 point or not. So I changed the inequality like this. But when the distribution is continuous, it does not matter. And then here you need to find two standard normal distribution cumulative probabilities. You need to find 1 and 2 and take their difference, which is not that difficult. Let's do that. So first, cumulative probability we are looking for is 1.5, right? Find cumulative probability at 1.5 and another cumulative probability at 0.5, minus 0.5. You get this number, and then you are going to take their difference to have probability in between them. So this is for probability z smaller than 1.5. This is probability z smaller than minus 0.5. So and their difference becomes probability in between these two numbers by taking their difference. Okay, so this is how you calculate the desired probability. Okay. Excuse me. Next, ambulance response time is measured as the time in minutes between the initial call to emergency medical services and when the patient is reached by an ambulance. So from receiving a call to actually the patient is taken by an ambulance is the time, how fast ambulance reacts to the calls. And for an emergency medical service station, the response time is known to be normally distributed, right, with mu 7.5 and sigma 2. Find the most appropriate number for the blank to complete the sentence. So at the station, 90% of emergency calls are reached within a certain minutes. Okay. This is about percentile. So we know x, so we define x as the response time, and it is normal distribution. And the information we have is 90% of calls reached within A minutes. A is the unknown we are looking for. A minutes. We can write that as probability that response time is within less than A minutes is 90%, right? So response time is less than A minutes is 90%, and what is A? That is the number to be here. And then first, I'm going to standardize the left-hand side. X becomes Z. A will be standardized in this form using mean and standard deviation, right? Again, another standardization question. And then now using the 90% information, this information, right-hand side information, we find 90 percentile. Okay, right? So below A, there is 90%. So that's the definition of 90 percentile. How can we find that? You have to use norm.s.inv. So inverse is the percentile. So enter 90%, which is 0.9. Then you get 1.28155. Right, simply, I am going to round to the second decimal place. So you can write it this way. And then finally, so in the first step, we expressed the unknown in terms of standard normal distribution. In the second step, we express 90% as a percentile. So we are going to connect, we connected these two things using standard normal distribution, right? And then finally, you have to match this. So this number must equal to 1.28. So you have to solve this out. So A must be, A is 1.28 standard deviations above its average. So if you solve this equation for A, you are going to get A equals 7.5 plus 1.28 standard deviation. So if you solve this out, then you will get the correct answer. Okay, the last question. During the spring, the demand for electric fans at a large home improvement store is quite strong. The store tracks inventory to order a new shipment of fans when the inventory level falls to the reorder point. If the demand exceeds the inventory, the store loses sales. So the manager would like to reduce the probability of shortage to 1%. This policy is called 99% service level in operations management. So idea is like this. Demand is random, but you don't know how much there will be demand, but you have to keep certain inventory to sell that, even if there is demand. But if you don't have inventories in place, then you cannot sell them, right? Here, suppose that the demand is normally distributed with a mean of 1000, standard deviation of 200, right? So then, for example, if your inventory is 1000, that means if the demand is more than 1000, still you could sell only up to 1000. So you need to maintain certain inventory. So we are going to consider this model. X is the demand for the goods. It is normally distributed with 1000 and 200 standard deviation. And we are going to denote the desired inventory level as A. A is the desired inventory level that satisfies the case where demand is greater than the inventory is only 1%. So the 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 problem, this is a problem when you don't have enough inventory. This problem happens only with 1%. You want to keep inventory at like to satisfy this problem to be less than 100%, like as much as 1%, right? So you are looking for inventory level that minimizes this problem to 1%. Here, like this is how we set up the inventory level, but I am going to rewrite that probability to this way because this is a cumulative probability, so later it will be much more convenient to handle. So the the probability that demand is greater than your inventory is 1% means 99% your inventory is more than enough to fill the demand, right? To meet the demand. So 99%, the demand is less than your inventory, so you'll be fine. That is what we are looking for. A is what we are looking for. So how do we solve this out? First, standardize the left-hand side. X becomes Z. A is transformed like this. Mean is 1000. Deviation is standard deviation is 200. So this is what we get. And now next, find 99 percentile. So below A, there is 99% probability. That means A is 99 percentile. So we find 99 percentile from normal distribution. So norm.s.inv, and I enter 99%. Then you get a number. Actually, it is this long, but I will simply take this number. Right, yes, here I round to the 4th decimal place, but you can reduce it. And then you are going to match, like you realize that this number must equal to this number. So then from there, you can solve for the unknown A. So A minus 1000 over 200, standardized A must equal to 2.3263. In other words, A must be 2.3 standard deviations above the average demand to minimize the probability of excess demand to 1%. Okay, so you can solve this out. It is easy to solve for A. Then you will get the answer. Okay, so this chapter was pretty straightforward, mechanical, like standardize, use Excel, right? And make sure you get a cumulative probability. These 3 steps are the key, and we are going to use these techniques in the following chapters. So you need enough exercise in this chapter. Okay, thank you for watching, and I'll see you next week in the next chapter.